discuss these images. Okay, let's start with atom. So we say atom is the basic, just like we discussed in cell, that cell is the basic unit of life. Here, atom is the basic thing of any substance, like any substance, even the cell. Cell is also made up of atoms. Okay, so when we talk about cell only makes are only like we use the term cell for living organisms only, but for atom we can include all living, all non-living organisms or all non-living things. Got it? All living and non-living things are made up of atoms. Atom is the basic thing of any substance. There is a term called as element. Do you have any idea about the element? Because we have to use this term again and again. Okay, sorry. Okay, you can tell. Good, good. So we say element is the simplest substance, okay, that consists of only one type of atoms. There is another term, compound. What is this? Compound is made up of two or more elements, like water. We say the water is a compound. Okay? Well, water is made up of hydrogen and oxygen, which are elements. So these are the basic terms that we should know because we need to use these in the in our further reaction. Okay, let's talk about cell. No, atom, sorry. Okay, an atom has three basic subatomic particles. That's right here. Three. Okay, here. Three subatomic particles. Number one is the electron. Number two is proton. Number three is the neutron. Though there are other as well, but we focus on these three subatomic particles. Let's talk about the electrons. Where do you think electrons are present? Around the nucleus. Good. Around the nucleus in a certain orbital. We call these orbitals. These are orbitals in which these blue color ones are the electrons. Okay? Okay. Let's talk about the nucleus. Nucleus mean the central thing. Okay. A nucleus is present. Now nucleus has both protons and neutrons. Okay? Let's say these yellow ones are neutrons and these red ones are protons. Now these three, we have to focus on these three particles. Okay. If we compare it, have you done the comparison like what charges are present? Okay. What charges are present on proton, electron, and neutron? No idea? We can write. We can write. No issues. Okay. Protons are positive, electrons are negative, and neutrons are neutral. Okay. What about their relative mass? So, what about their mass? Their like the mass. Yeah. The protons are the heaviest one, and protons are almost equally weighs as neutrons. So this is the table that we must know. This one is the important one. The neutron and protons are relatively equal in weight, while electron is very, very small as compared to these one. It's about 1 by 1850 times lighter than the other one, the other two. Okay, are really light, yes. These are present in nucleus, and this is around the nucleus in orbitals. Okay, this is the very first thing that we must know. Okay, how to calculate a proton, a neutron, or electron number? Because we need to discuss bonding, we must know how to calculate the electrons, how to calculate the protons, and how to calculate uh, the other one. What do we call it? The neutrons. Any idea? No? Okay. The proton number, electron number, and the neutron number. Okay. Do you know how do we use periodic table? Okay. Okay. Do you have a periodic table? Okay. Just download one image because we are going to use we have to use the periodic table for this lecture. Download a simple one with like whole numbers. Do not download it with like the other one, which gives the point in decimals. There are some which use the decimals one. Don't go for the decimal ones. If you couldn't, I can give you the one. Okay. Let me send you in the chat. Okay. Is it visible? You can't see anything? Okay, wait. Um, Let me send you one more time. Is it blur or black? Black. Uh, are, are you using the dark background on your phone or whatever device you're using? Okay, can you please convert it into a like the white background? Okay. So that's the issue because my the screen also has the other one option. I look as black. We need to change the like. Um, or let me send you a screenshot. That would be better, I guess. Shall I send you a screenshot as well? Let me send you a screenshot. So that won't be there won't be any like black background. Just check the screenshot that I've sent just now. Okay, better now? Okay. There is a key given. Okay, let me check with the other one because when I take a screenshot, it gets blurred. I don't know why, but it gets blurred. Yeah, it's getting blurred while taking screenshot. There is no way around. Can I give you the image, the link from where I'm getting the image? I want you to use the whole number one, not the decimal one, because we need to calculate certain things from that. If we use that one with the like decimal one, it would be like really difficult for us to calculate things. Okay, if you're comfortable in that, you can use the other one. Let me check if I can get the other one as well. Okay, do tell me now if you are able to see this one. I hope this one is not with the black background. It's better, right? Okay. Let's make a key for this one. We have to use a certain term. One is called a symbol. On the top of symbol is the atomic number, and the bottom of symbol is the relative atomic mass. Oh, wait. Just give me a minute. A relative atomic mass. Let me write and then I'll just focus. Okay. For oxygen, let's talk about this oxygen. For oxygen, 8 is the atomic number and 16 is exactly. Good. So, how do we calculate electrons and protons from this one? Like we have oxygen, let's say. How many electrons, how many protons are present in this one? So this atomic number, it represents the number of proton or number of electron in an atom, not about the ion. I'm not talking about ion. I'm talking about atom right now. Okay? There is a difference. In ion, there are different number of electrons. Okay? And we'll learn it later. We'll learn it later. How do we do this? We'll learn it later. But in an atom, number of protons and number of electrons are equal. Okay? In atom, let's write here. Protons are equal to electrons. So this oxygen has 8 electrons and 8 protons, right? Okay, what about the chlorine, Cl? Chlorine, yeah, Cl. What's the proton number and what's the electron number? 17, good. Okay, what about sodium? Sodium is Na. Yes, sodium, Na. 11 electron, 11 proton. Good. Okay. How do we calculate neutron? There is a formula that we need to use. Though it's a simple one. The atomic mass minus atomic number. Okay. Let's calculate it for sodium. Sodium is 11 and 23. Okay. How many neutrons are there? 12. Good. How many neutrons are there in magnesium? Next to it. 12. Good. So this is the basic thing that we should know. Okay, because our next topic is related to isotopes. Okay, what are isotopes? Isotopes, okay, do you want to say something? J, wait. of, not electrons, the neutrons. Different neutrons. They are same form, basically the same element. There are different forms of elements which have same atomic number or same proton but different neutron. Okay, let's move to the first example that I've pasted. These are three isotopes of hydrogen basically. Okay, if you look at them, they all have one proton, right? These all have one proton, but the number of neutrons are different. Here we have zero neutron, here we have one neutron, here we have two neutrons. Okay, so you know about the isotope. Okay, let's talk about ions. What are ions? Let me change the color. Okay, once you learn about ions, you learn about the bonding as well. Ions are, yeah, the ionic bonding. The protons are not equal to electrons. Electrons, because they are present in the outer premises, they tend to leave the electron. They are very naughty. They leave the electron. Okay, or might be they just invite new friends. So there may be lesser number of electrons or there may be more number of electrons. Are you getting me? Okay, so when the electrons leave, there would be less electrons, right, than protons. This is known as cation. And the anion one are in which the electrons enter and there are more electrons than protons because their number are not equal, right? Now I want to tell you something which you really need to note down. Okay, if we talk about this first one where hydrogen is written, the charge on it is +1. Okay, what do we call it? We call these groups. These are groups. These columns, these are called as groups. Each group has a certain charge. Okay, so this first group, it has a +1 charge. The second group, it has +2 charge. This is technically the third group. It has +3 charge. This fifth group, it has -3 charge. The sixth group, it has -2 charge. This one has -1 charge. It has 0 charge. And this one has a equal capability of gaining plus or minus. Both charges can be present. +or -4. It can either gain electron or lose electron. Now let's move to ions. What is the purpose of making ion? Why they are so important and how do they make bond? The rest of these, okay. These are the transition one. They may have different type of charges. Like if we talk about iron, iron also has a +2 and +3. Okay, copper has +1, +2. They have multiple charges. So we usually don't discuss these ones, the middle ones, in your syllabus. According to your course, we do not discuss them. Okay. Okay, what I was going to tell. Okay, the ideal condition for any atom except this first hydrogen helium is to gain ideal. Why the ions are formed? Why there are lesser or more number of electrons? Now ideally an electron or outer shell must have 8 electrons. Okay, so to get this number, the atom tell the electrons to enter or tell them to leave so that it can have 8 electrons in the outer shell. Let's okay, do you know about how these electrons are arranged in a periodic in an atom? Like there are certain shells and shell numbers. Good. Great. Great. Okay, let's talk about sodium. Where is it? Let's talk about sodium. Okay, the charge on sodium is plus 1. So if it has 11 electrons, there would be 2 in the first shell, 8 in the second shell, and how many would be there in the last shell? 1. Okay. So instead of getting 7 electrons from other atoms, it prefers to lose 1 electron. If it lose 1 electron, there would be a charge of plus 1 on it. And in this way, it would have 8 electrons in the outer shell. Okay? Let's talk about chlorine. Now, chlorine is 17. Can you please arrange the electrons? The first shell would have 2. Second, last one. Now, what is easier for this one? To gain 1 electron or to lose 7 electrons? To gain 1 electron. So, it would gain 1 electron and becomes 8. And there would be a charge of minus 1. So charge depend on how much electrons are needed or are needed to be lost loose in order to get 8 electrons. Okay? Okay, there is one more thing about the periodic table. I don't want you to confuse about that, but it's very like basic. Let's learn it later. Let's focus on this, like how they make, how do they gain charges? Okay, next one. When we talk about ions, and there are two type of ions. Now tell me, if sodium and chlorine wants to make a bond, can they exchange electrons? Not exchange, can they give and donate electrons? Can they gain or donate electrons? Yes, they can. So sodium can give 1 electron to chlorine and they can make a bond. Simple. Okay, this is ionic bond. It's a transfer of electron from one element to another element or from one atom to another atom. Shall I tell about these again? Shall I repeat? Okay. Um, in an atom, the protons are equal to electrons. Now, sometimes, or the ideal condition for an atom is to have 8 electrons in the outermost shell. That's why if you look over here, I haven't write, I haven't written, sorry, any charge on the periodic table for 8th group. I've written 0 over here. Why? Because this 18th group has 8 electrons in the outermost shell. So they do not give or donate electron. They do not get electron. Okay? Because their outer shell is complete. They are more than happy. Our outer shell is complete. Why do we need to make a bond? But in case of other atoms, when they want to have a perfect electronic configuration, they tend to lose electron or they tend to gain electron in order to get 8 electrons in the outermost shell. Okay? Okay. Let's move back to this periodic table because I have a question for you. Okay. I'm copying this question because you need to tell me the answer for this one. There is one question. An element is defined by the number of dash in its atom. How do we define element? What is the basis of an element? How do we name elements? Okay, no idea. How are these elements arranged in the periodic table? They're arranged on the basis of their proton number. So answer would be proton. Yeah, the answer would be proton. This is the answer. Okay. can I ask you like about the chemical symbol and atomic number of the different things? Okay. Since it's not written in the periodic table, let me see if I can give you another one. No, I don't have another one. Okay, what is potassium? What do you think? Where is potassium? Over here. What is the symbol of potassium? It's not P. Do you have any idea? It's K. Okay, what would be the charge on K? Plus one. Good. Okay, now let's make a bond of these elements. Okay? Okay, let's talk about sodium and then let's talk about the chlorine. Do you have any idea about like of how to make a like how to represent a bond? No. You mu Have you ever drawn it? Okay. So let's go through it. It's not that much tough. Let's make a bond between sodium and chloride. Okay. The very first thing, let's write the steps. The very first thing that you must know is the number of electrons in the outer shell. Okay? This is the very first thing, very basic thing. Second thing, second step is you need to show the transfer of electrons, like from which atom to which atom. Okay? And you have to use differential key. Okay, sometimes we use different colors, sometimes we use dot and cross. Okay, what have you used at your school? There are two different methods. So colors are most of the time not available, so we prefer to write positive or negative, or we can use dot and cross. You there? Okay, there can be two things done. I think positive and negative is like more of a confusing one because that would be like the last step. We should use dot and we should use a cross method, let's say. Okay. When we represent the outer shell of this sodium, how many electrons are there? One. Okay? A one dot is there. For if I'm writing about chlorine, it's a normal atom. So it would have seven electrons. So I'm making it with I'm differentiating it with cross. Okay? While a bond is made, this is transferred over here, right? It becomes sodium because the electron is lost, and this chlorine it would get one dot. Now dot would remain dot. Keep this thing in mind. Just to show that this one is transferred from sodium. Okay. Can you make a bond with between magnesium and no that would magnesium and oxygen? Okay. I'll be waiting for you. You need to send me that in chat. Okay. Just represent the magnesium outer electrons and the oxygen outer electrons and then show the transfer of electrons. Don't forget to put the charges, the positive or negative. Okay. Great. Good. Okay, now let's discuss more things now. Keep in mind the the similar sorry, the similar charges cannot make ionic bond. They can make covalent bond, but they cannot make ionic bond. Okay, if you look at this periodic table, what do you think? Okay, the similar charges, like if it's plus 2 or plus 2, they cannot have an ionic bond. Have you got me? Positive have to make bond with the negative one. This is the only thing that we have learned. That is the transfer of electron, right? One is giving and the other is taking. So one should be positive, other should be negative. What do you think? Uh, can oxygen make bond with nitrogen? According to this one, the covalent bond? Sorry, the ionic bond? No. The covalent it can make, but what about the ionic bond? No. Good. Okay, this is the one thing. Second thing, the ionic bond is always between the metals and non-metals. On the like till here, till group 3, these are metals. This one, till here. Here. These are all metals. Okay? These are metals. Metals make ionic bond with non-metals. Can group 18 take part in not making non-metals? Oh, sorry. Sorry, let me rephrase it. Can group 18 make ionic bond with any of these? I'm talking about group 18 with zero charge. No, because it cannot. It has complete outermost shell. It preferred not to give or take electron. Okay. Helium, argon, neon, krypton. These all have complete outermost shell. Okay. Group 18 is not going to make bond. Ionic bond, specifically. Okay, the next thing, again related to the ionic compounds, how do we name it? Okay, the metals would remain same, the metal name would remain same. It would be like sodium, sodium remains sodium. Magnesium, it remains magnesium. The positive ions, they do not change their name. Wait, here. Its name is sodium. Where is my pen? It's sodium, it would remain sodium. But this was chlorine in the periodic table. When it gains electron, it would become a negative ion. The negative ions end with IDE. So it would become sodium chloride. What about this magnesium and oxygen? Magnesium remain magnesium. Oxygen becomes oxide. So the name would be magnesium oxide. What about this? Because I'm going to give you one question related to it. It's barium and sulfur. What would be the name? Barium sulfide. Okay. Let's talk about the Lewis structure. This is the one that I use for like the simple understanding. Let's talk about the Lewis structure. The Lewis structure is simply represented by dots only, and we have to represent the plus and negative charge. Okay? And we use the Lewis structure most of the time. Now I have one Lewis structure for you. You need to tell me which one is the correct one. Oh, no, sorry. Oh, I've pasted your image. Wait. Uh, I don't know where. Okay, here. Here, I have the image. Here. It's related to barium and fluorine. Sorry, not about this. Barium and fluorine. Which one is the correct one structure in your view? Look at the charges which are given in the periodic table. The barium and fluorine. Where is barium present? In which group it is? And where is fluorine present? What can what can be the charge on barium? What can be the charge on fluorine?